So like last week, this will not be an easy class. And it's absolutely normal if you're gonna feel confused or if there is something that is not clear. So just do not hesitate to ask questions, or if you have some issues with the exercise, we're gonna work them out. So today we'll still be talking about loops, and precisely we will see the while loop and two control statements, the continue and break statements. So from last class, if you remember, we saw the for loops and the nested for loops. So last class we said that the for loop is composed by the index, and then the starting point, the end point, and that's basically and then the body of the for loop. So here, for example, for the index that starts at 2 and starts at 1 and ends at 2, then when we print the index, we're gonna have like as an answer 1 and 2. If here it was like 3, then it would have end up at 3. If we want to actually display or just access the elements inside a vector or just a general array, and so we don't want to only display the index, then we have to access the array. And we do that using the index to find the position of each element inside the array. And so in this case, we'll have for the index from 1 to the length of the vector, in this case is 3. And then we access each element of the vector using the index. And so here the answer would be 2, which is the first element, then 4, which is the second element, and then 6, which is the third element. Then we also saw the nested for loop. They're exactly like the for loop. The logic is the same, but we just have like a for loop inside another for loop, or like multiple for loops nested together. As I said, the logic is the same, but it's very important to remember to indent the for loop, because otherwise it's just going to be a mess and you don't know which statement belongs to which for loop, and then it's going to be very hard to understand what you wrote. So today we're going to talk about the while loop. So the while loop repeatedly executes statements while a specified condition is true. When the condition is not true, then the loop stops. So for example, I hope that we're really 136 credits to graduate from Artisten. I think it was the behavioral neuroscience major. Okay, great, I remember well. So we need 136 credits to graduate from Northeastern. So while you have a number of credits that is less than 136, then you have to keep accumulating credits, otherwise you cannot graduate. Once you reach 136 credits, then you stop accumulating credits because you don't need them anymore. And so that's exactly what a while loop does. So basically, you're living in a constant like while loop. That's the truth. So here's the formal code. Let's assume that we are our last semester of the 4th year, and we already have 126 credits. And so we set the counter at 126, and then we write my credits, so 126, until like if the credits are like while the credits are less than 136, then my credits are equal to my credits plus 2, assuming that is the number of credits for each exam. I have no idea. So let's try to see what happens if we run this in MATLAB. So Let's see. And here you can see that basically displays all the credits, like 120, starting from 126. Sorry, here the window is not super. Okay, so starting from 126, it just like keeps looping. And then it adds like 2 credits up to 136. And once it reaches 136 credits, then the while loop breaks. A super important thing to remember is that sometimes when you use a while loop, you might get stuck in an infinite loop. And the only way to exit this infinite while loop is to press Control-C multiple times. I think 3 times is fine. I just like keep doing in rapid succession, and it works. Otherwise, the alternative is to destroy the computer. That also break the loops, but I haven't figured out an alternative way. No, literally, it's like everything's like just gets stuck, and sometimes you really have to, if you don't remember this, you will have to probably switch your computer off and lose everything you're doing up to that point. So please remember Control-C, and remember it now, because it's going to be an exercise where you're going to get stuck in an infinite loop. So remember it, otherwise I hope you saved all the documents you're working on, otherwise you're going to lose everything. Let's try to practice up to the control statement part. So there are a couple of exercises that are, I think, pretty challenging. So maybe you can work on them in group. Oh, also, I forgot to record. Let me just share the screen 1 second. I just wanna, because I did the same and it basically works. That's what I did. Oh, sorry, you put my what is it, smaller than 800. It's actually bigger than 800.
Wow.
That's the difference, because we go like, then we subtract to 2000, and then like we keep going with this loop, like as long as it's like you have more than 800 bucks, and then when you have 800 bucks, it stops because you need to pay the conference travel.
Yeah, it works now. I just changed the sign. Yeah, just like Stephanie just said, like it doesn't run because 2000 is greater than 800.
Yeah, yeah, exactly. I don't know why I saw the sign on the opposite version. Yeah,
I got it.
For
perfect.
anyone else, like it works for you, Leslie, but when I run that, for some reason, every answer is like the number twice. So like it's like 875 there twice.
Did you display the, did you do that? Like
yeah.
Because if you display the grant, then it's also display the grant. So if I do that, it's gonna,
Wow.
yeah, you see?
Yeah.
It's very useful to display things, and you should always do it at the beginning, especially with more complex loops. Otherwise, you don't know what happened, and if you have like an error, then it's hard to know which is the last part that actually works. So if you keep displaying things, then you have a more general understanding of your code. But then you have to remember to suppress the output or just to eliminate the display, otherwise it's going to be redundant.
Gotcha.
Okay, so do you want to try the second one, and I'll check in a few minutes? Nice.
Yep. Is if the number is an even number, when it divided by 2, and then the remainder should be 0. And then it will display that this number is even. And if that's not the case, it will display it as odd.
I think it works. Does it work? Did you try to run it? Because it does make sense.
I don't know. It only prints 1.
Huh. Did you, 1 second. There is a problem here. So you put like if and else, and then you end the if else statement, but I don't think you could, yeah.
Like here or?
Yeah, but you need an and for the if else statement, and you need an and for the while loop.
Oh, okay. Okay. So how
yeah,
about
also
indentation?
yeah, exactly. There is also like if you go you know, like editor, and then like on the menu bar, no, up, there is like indents.
Okay, got it. Oh, I
It
think it's
works.
working. Yeah.
Yeah, nice. Okay. I don't remember if there were other exercises of this part. I think it was the last one, because then you have the continuous statement. Okay. So let's go back to the slides.
I just have a question. So like for the mod, how do you know you have to put like the is equal to 0 at the end? I don't see that in like any of the documents.
Oh yeah, no, just because like, you know, every number that it's even, like when divided by 2, there is not reminders.
Oh, so you have to put what you want it to be.
Yeah. But it's not like related to the mod's function.
Right.
Okay. So now we're going to talk about the loop control statement. So basically, you can force loops, for and while loops, both of them, to do stuff, everything you want. So you really are in control of the situation. So for example, you can break the loop if a particular condition is met, or you can skip an element of the loop and like keep going. So the continuous statement is used for passing control to the next iteration of a for or while loop. So basically, so you can use it for both, with both loops. And it just keeps like a line of code, for example. I found this example online just for disclosure. So here we have a equals 10. So while a is smaller than 20, if a is equal to 15, then we skip the iteration. I can do it. Otherwise, we just keep adding 1. And so, and then here we print the value. So here, the code, the results of the code is going to be a equals 10, 11, 12, 13, 14. When it arrives to 15, it skips the iteration, and then it goes directly to 16 up to 19, because the 20 was the limit. For the break statement, it's very similar to the continuous statement, and it basically just terminates the execution of a code when like you declare that a certain condition is met. So for example, this previous example, if we can even put if a equals to 15, then break. So when it arrives to 15, just the loop breaks. So here, for example, a equals 0, so the counter is a 0. For I equal 1 to 10, a equals a plus I. So here we have in the first iteration a equals 0, and then I equal 1. So a equal 1 at the end. Then the second iteration, a equal 1 plus 2, because I is equal 2. Then the third one is I equal 3 plus I, and then the I is equal 3. So it's going to be 6. Then 6 plus I equal 4. And so all the way up to 8. When I equal 8, then the code breaks. that starts to get tough, but let's see what, what we can do. So I'll be around, and good luck. We have 1 minute and one more slide to go. Perfect. There is another type of for loop. Can you imagine? No, but we are not gonna go into the details of this type of loop, at least in this course, because to be honest, I never used it. But I wanted to mention that this loop exists and is called par4 loop. So it's very similar to the for loop, but it works in parallel. So all the data is worked out at the same time, which is great because it makes it very good for simulations. For example, when you like simulate like huge data set with thousands of repetitions, and then it's gonna take just forever to run. But if you analyze all the data at the same time, then it's gonna be very quick. So of course, it's much faster than a regular for loop. There is a main difference with the for loop, and the difference is that the body of this par4 loop must be independent, which means that you cannot nest par4 loops together. So you can do like a nested for loop, but you can never do a nested par4 loop. And why you can never do a nested par4 loop? Ideas? I guess.
Because it works in parallel.
Exactly. So you can, so it's basically, yeah, exactly. So there is not really an order. So you cannot, it doesn't make sense to nest it. It will actually give you an error. There are some way to like modify a nested for loop, like and convert it into like a par4 loop. So in case one day you want to do that, just remember that it's possible. And here there is a link to the documentation, but in case you're interested in another MATLAB course from intermediate to advanced, then we're gonna see this loop in the detail. For now, you just should know that it's something that exists. So we finished all the loops part, and I think the next time we can work on some like real data. So the project and practice some visualizations. MATLAB is great for visualization, so it's going to be a lot of fun. And the toughest part of the course is gone, because there was like probably this class and the past class. Yeah, so questions?